this is Algebra 1, Lesson 70. We're going to talk about probability and designated order. We're starting on page 284. Probability is the study of outcomes that have an equal chance of occurring. For example, assuming fair play, a coin has an equal chance of landing on heads or tails. Or a six-sided die has an equal chance per side. The result of a probability experiment is called an outcome, and the set of possible outcomes is the sample space. The sample space of a coin toss would be heads or tails. The sample space for a six-sided die is 1, 2, 3, 4, 5, or 6. We find the probability of a particular event with this formula. Probability equals the number of outcomes that satisfy the requirement over the total number of outcomes in a sample space. The probability of an event is always going to be between 0 and 1 because it's a fraction. And the number of outcomes that satisfy the requirement are never going to be more than the total number of outcomes in the sample space. This makes more sense if we think about probability in terms of percentages. If we say there's a 50-50% chance of rain, that means there's 50% chance that it will rain and 50% chance it won't rain. So 50% is 1/2, which is between 0 and 1. Or 50% is between 0% and 100%. Okay? So here's our first example. A fair coin is tossed. And when I say fair coin, I don't mean a coin that you got at a carnival. I mean a coin that is not weighted on one side. So there is an equal chance of it landing on heads or on tails. So a fair coin is tossed 3 times and comes up heads every time. What is the probability that on the next toss it will come up tails? Tossing a coin is an independent event. The results of past independent events do not affect future independent events. So it doesn't matter what the coin landed on next time or last time. There's an equal probability this flip that'll turn out heads or tails. So to find the probability, we take the number of outcomes that are tails. So we have one coin. There's one possible number of outcomes that would be tails over the total number of outcomes in the sample space. In this case, it's a coin toss, so there are 2 possible outcomes in the sample space. So the probability is 1/2, or 50%. 6 green marbles and 8 red marbles are placed in an urn. 1 marble is drawn, then dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were red. If another marble is drawn, what is the probability that it will also be red? Since the used marbles are being dropped back into the urn, this is also an independent event, and the past events have no bearing on future events. The probability of the next marble being red is going to be the total number of red marbles in the urn over the total number of all of the marbles in the urn. In this case, there were 8 red marbles, and there was a total of 14 marbles, which gives us 8 over 14, and we can divide the top and bottom by 2 and simplify this a little, so it'll be 4/7, and that would be your answer. A single die is rolled 3 times. The results are 1, 4, and 2 in that order. What is the probability that the next roll will produce a number greater than 2? Rolling a die is an independent event, so the past results do not count. The sample space of a 6-sided die is 1, 2, 3, 4, 5, and 6. The number of possible outcomes that are greater than 2 is 4. So probability is going to equal the number of outcomes that is greater than 2, which is 4, over the total number of possible outcomes, which is 6. And then we can simplify that to 2/3, and that would be your answer. All right, let's get a little more complicated. 2 dice are rolled. What is the probability that the sum of the numbers rolled will be 7? So on page 285 in your book, they were very nice to you and gave you a nice graph, which shows the diagram of the sample space. So here's the outcomes on the first die and the outcomes on the second die. And when you add the results together, here's your possible sample set. 1 plus 1 would be 2, 2 plus 2 would be 4, 6 plus 5 would be 11, okay? So this is your sample set, because there are 6 sides on this side and 6 sides on this die. That gives us a sample set of 36. And the number of probabilities that are that equal 7 are 1, 2, 3, 4, 5, 6. Okay, so we count the number of solutions that are 7. And there were 6 of them. So the probability is going to be 6 out of 36. We can simplify that to 1/6. Okay, the next question is 2 dice are rolled, and what is the probability that the sum of the numbers rolled will be greater than 8? So we pull out our chart on page 285 again. Here are the numbers that add up to greater than 8, and if we count them, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 possible solutions that will add up to greater than 8. So the probability equals 10 out of 36. We can divide both of those by 2 and get 5/18. And that would be your answer. You have done probability before in other math classes. But here's the new twist. Now we're going to talk about designated order. The probability of future outcomes of independent events happening in a designated order is the product of the probabilities of the individual outcomes. For example, if we toss a coin twice, the probability of getting heads on the first toss is 1 out of 2, right? The probability of getting tails on the second toss is 1 out of 2. The probability of getting those tosses in that order, so the probability of heads and then tails, is going to equal the probabilities multiplied times each other. So 1/2 times 1/2 is 1/4. This makes sense. Our possibilities for 2 tosses are heads and heads, or heads and tails, or tails and tails, or tails and heads, right? So there are 4 possible outcomes, and heads and tails, this one is just 1 out of the 4. So we can prove that this is true. Okay, so now a fair coin is tossed 4 times. What is the probability that the first 2 times it comes up heads and the last 2 times it comes up tails? Okay, so our formula is the probability of heads, heads, tails, tails is going to be the product of each of these individual events. So the probability of it turning up heads is 1 out of 2 times. The probability of it turning up heads is 1 out of 2. The probability of it turning up tails is 1 out of 2. And the probability of it turning up tails again is still 1 out of 2. We multiply these together and get 2, 4, 8, 16. So this is 1/16. Okay? This means there is a 1 out of 16 chance that the coins will land in heads, heads, tails, tails order, which means that if you write out the entire sample set, there should be 16 possible combinations of heads and tails with 4 coins. For extra credit, make a list of those 16 combinations and bring them into class on Monday. Okay? I'll give you extra credit if you write down all 16. Here's another example. A game spinner, you know, one of these guys, with 4 even spaces is spun twice. What is the probability that a spinner stops at a 4 and then at a 3? So there are 4 equal spaces, so the probability of it stopping on a 4 is going to be 1 out of 4, right? The probability of it stopping at a 3 is also going to be 1 out of 4. So the probability of it stopping at 4 and then at 3 is going to be 1/4 times 1/4, which equals 1/16. Okay, that's it. Try your practice problems. Do all of the problems from this lesson. And let me know if you have any questions. Thanks.